Alright everyone, welcome back to the day 28 of our daily leetcode challenge, and today we have got maximum number of fish in a grid. So in this question they have provided us with a matrix of order m cross n, meaning it has m rows and n columns, and it has values such as zeros and non-zeros values. So wherever there is a zero value, that basically means there is a land there, like all these zero values are nothing but land, and wherever we have a non-zero value, those values are the water, and the value at those particular indexes where we have a water is these values represent the number of fishes that we have. So this value right here represent, it has got 4 fish right here, 1 fish right here, 4 fish right here, 3, 2, 1, 3 and 2, and wherever there is a 0, all those are land cells. So we as a fisherman, what we need to do is we need to tell what is the maximum amount of fish that we can gather if we decide to start fishing from any one of the water lakes, any one of the lakes. If we choose, what is the maximum amount of fishes that we can get. So what I mean by that is, let's say that I start fishing from this index right here. So there are few rules in the way we are gonna fish. So first is that we are gonna have to collect all the fishes in that particular cell. Let's say I'm starting at this cell right here. If I'm starting at this cell, then I need to collect all the fishes in this cell, and then move adjacent. Adjacent again would here me in moving in all 4 directions. In all 4 directions we'll have to move after collecting all the fishes from a particular cell. We'll have to move in all 4 directions. So in that case, having said that, if we start fishing from this cell right here 3, so far we'll add 3 to our answer, and then we'll move to the all 4 directions, so which would be here 1, 2, 3 and 4, and we'll have to do a few checks wherein we have to understand, alright, there are certain conditions, as in when we reach that condition we'll have to add 0. Firstly, if we reach a land, here 0 indicates a land, then there would be no fishes collected. So while moving left, we see that we got a 0, and if we move up, we again saw a land, so we'll get a 0, and if we go right, then we see that we have a 2, so we add 2 to the answer, and if we move down, we are going out of bound, so in that case also we'll have to add 0. So if we start fishing at the cell 3, we are gonna end up having 5 fishes in total. So this was when we started with 3. Now if we started, let's say, at this cell right here 3, in this one, then we'll have to collect all the fishes in that cell and then move in all the 4 directions for this one, in all 4 directions. So if we go up, we are approaching a land, so that's a 0. If we move left, we are again approaching a land, so that's a 0, and if we go right, we are going out of bound, and if we are going out of bound, that is also a 0, and if we move down, we'll be having 4, so we have 4 as the answer, and so this was 7. And if we, let's say, take this cell right here to fish, this cell right here, then for that we'll have to add first the fishes in that cell, which is 2, and then move in all 4 directions, which is like all the 4 adjacent cells. So if we do that, if we go up, we are going out of bound, so that's 0. If we go left, we are reaching a land, so that is again a 0, and if we go down, we are again reaching a land, so that's a 0, and if we go right, we are reaching a 1, so we add that. So if we start fishing at this cell, we are going to get a 3. Now let's take example of this one. What if we started fishing at this cell 4 right here? So if we take 4, then we'll have to add 4 to the answer, so we added a 4, and then we go to all the 4 directions. So if we go left, that's an out of bound, so that's a 0. If we go up, we reach a land cell, that's 0. If we go right, we reach a land cell, that's 0, and if we go down, we reach 1, so we add 1 to the answer. The final answer gets 5. So far we saw that if we select all the possible cases, we'll be ending up with 5 fish, 7, 5, and then again 3 right here for this one, 3, and the max out of all these values is 7, meaning that if we start with this cell right here, start fishing from this cell right here, we are going to end up with the max amount of fishes that is possible, which is 7. So this is what they want us to know, like what is the max amount of fish that we can gather if we start fishing optimally. By what they mean is, for us in this condition, fishing optimally would be fishing from this cell right here. If we start from this cell right here, we'll be end up having the maximum fishes, which is 3, this one, and that answer for that case was 7. So if you see, what we are doing here is nothing but the DFS. Here what we are doing is, we are again going in all 4 directions, and this is kind of becoming a recursive call. So what I mean by that is, let's say that there were more fishes in these cells right here, or there were more cells added. In that case, for these cells as well, we'll have to go in the all four directions. So this kind of becomes a recursive pattern, and whenever there is a recursive pattern, we'll have to make sure that we come up with certain conditions that help us terminate that recursion. So in this example that they have provided us, few we already saw, 3 of them we already saw. First is that if we go out of bound, that is if the row is greater than equal to 0, if we are going out of bound, that's 1, column is greater than equal to 0, or row is getting less than 0, column is getting less than 0. These 4 conditions tell us if we are going out of bound. That is one way to know, that's when we need to terminate the recursion. The other way is that if we reach a land cell, then also we need to terminate the recursion. We need to know further go in the all 4 directions if we reach a land cell. That's second. And the third is if we again visit a already visited land, like in this case 4 and 1, when we reached 1, we added 4, and then we came to 1. Now in the case of 1, when we will do that, we'll see that we'll go back again to 4, because in the case of 1, we will be doing all the 4 directions again, and in that case one of the direction will be going back to 4, and since 4 is already visited, so we need to terminate that loop, that recursion as well. So that's where the visited set will help us to kind of terminate the recursion. So there are 3 conditions that we're going to look for. First is going out of bound, and the second one is to check if we reached a land cell, and the third, which basically means if we reached a 0, and the third one is to check if we already if we came up to a visited cell. If we came up to a visited cell, then also we need to terminate the recursion. So these are the 3 ways wherein we are going to terminate the recursion that we're going to have. So this is what's going to happen. Let's take a look at the second example now. If you take a look at the second example, you'll understand this a little better. So the second example, let's take a screenshot really quick. So this is the second example right here, and let's try to do what we did with the first example on this one. We have all of these mostly are land cells. Wherever you see a 0, all these are land cells, and wherever we have a 1, that's a water cell. So only two options we have. First is to either start from this cell right here, or we start from this cell right here. Let's see what is the maximum amount of fishes we are getting. If we start at this cell right here, 1, we'll have to add 1 to our answer. That's first. We'll add 1 to our answer, and once we add that to our answer, we'll have to kind of move to all 4 directions. All 4 directions will have to move to find further more fishes which are adjacent to this cell. So if we go up, we are going out of bound, that's a 0. That's where this is basically the condition of our recursion. So basically what we're going to do is we're going to add this to an answer, and then again call our recursive function. Let's say I'm calling it as a DFS, and then whatever row and column we have, we are going to add a +1 to the row to go up, and then we discussed this in the previous questions as well. This is how you basically do the all 4 movements that we do. This is our recursive function getting called again for the recursive part, which is going in all the 4 directions. So these are the 4 functions that we'll have to call in order to go to all the 4 directions. This will take us to the upper row, which is kind of going up. This will help us move to the right. This will help us move down, and this will help us move left. So we do all these 4 directions. We move all to these 4 directions. At some point, we'll have to kind of terminate these recursive functions by returning a value which will be 0 in the case if we terminate the loop. How will that be? If let's say in this case, if you see we are going up and it's going out of bound, so this recursive call has to be terminated, and in that case we'll return a 0. This will return a 0. Let's take a look at this example. We are going right here, same row but column gets increases. We are going right here. In this case we reached a 0. In that case also we'll have to need to terminate that recursive function, so we'll return a 0 in this case as well. And if let's take an example of this one, we are going down here. In this case again we reached a 0, so this gets again returned a 0. And then in this one where we are going kind of to the left, the column gets decreased, we are going to the left, we are again going out of bound, so this will also return to a 0. So eventually after doing all those recursive calls and terminating the loop wherever necessary, we reach the conclusion that the 1 is what we are going to maximum get for if we start 1 is what you're gonna get if you start fishing from this cell. Now also this would get added to the visited set, and all the traversed will also get to the visited set. Even though they are terminated, we'll have to add them. And the same treatment will go for this cell as well. We added this to our answer 1 and then move to the all 4 directions, this 1, 2, 3 and 4. So 0, 0 again, and then 0, 0 because of the out of bounds. 2 zeros we are getting because of the out of bounds, and these 2 zeros we are getting because of the land cells we are reaching. So in this case the answer would be 1, because 1 is the maximum fish we can get, be it from 0, 0 or 3, 3. In both cases we are gonna get 1. Let's try to take a look at this example again, but this time let's add certain water values instead of land cells. Let's add some fish values and see how it will change the answer. So let's say that I have, instead of zeros, I'm going to place it with certain values now. This will help us understand the question slightly more better. Alright, so we have a 0 here initially. Let's add some water, instead of these land cells, let's fill them with a little bit of fish values. So let's say I add 7 fishes here, and adjacent to it I added 2 fishes here, 3 fishes right here, 5 and then 7 here, and 1. So what we need to do is, in order to solve this question, so far we know that for each cell we have to move in all 4 directions. So again what we'll do is we'll iterate the entire matrix. Wherever we find that a cell has a non-zero value, or that would mean that it has some fishes in it, we'll add that to the we'll consider that cell value as one of the answer, and then again whatever we get by moving in all 4 directions. So in this case we first reach a 1, we start from 0, 0, we reached a 1, we take its value 1, then comes the recursive part, moving in all 4 directions, which is these 4 directions. So if we go right, we reached a land cell, we see it's a 0, so we add a 0. If we go down, that's a land cell, we add 0. Going up and going left are both out of bounds, so we add a 0 and a 0. So these are nothing but the values we are getting from the recursive call, which is the same function getting called DFS. We are going to define a function as DFS rc plus 1, as I drew earlier, rc plus 1, r plus 1 c, r comma c minus 1 and r minus 1 comma c. These are the all 4 direction movements that we are going to do. In this particular cell 1, this is the answer we're going to get, which is 1. Now we move further, we reach cell 7. So we add this to our answer 7, we reach this cell, I add this to our answer first, and then every time we get a value, every time we get the final count, the number of fishes we can get from this cell right here, we will have to add this value back to like we need to find the maximum, right? So we'll also define a list. This will be our answer list, and here we're going to keep appending values. Whatever values we get for each cell, we're going to keep appending that, and in return we are going to just return the maximum. Or we can also define a variable called max value, and then every time we get a value we can compare that. That is also another way of doing it without creating another list. So we'll deal with that later, but first let's try to understand how this DFS part is working. So we are right now at this cell, and then again we are going to move in all 4 directions, which is left, bottom, right and top. So if we go right and top, you see we are going out of bounds, so that's a 0 and a 0. And if we go bottom and left, we are again reaching land cell, so that's a 0 and a 0. So for this case we are having 7 fishes at max. Now let's come at this cell right here, where we have a 7 here, right? So in this case we're going to add 7 to our answer. Let's add that, and then again we're going to move in all 4 directions, So if you see, these 2 loops are getting terminated by default because we are reaching a land cell, so that's a 0 and a 0, and then again we reach this cell right here 3, and this cell right here 2. So let's start with 3 right here. Now this again becomes a new DFS. Now we're going to do the same thing which we did for 7 for 3. We'll add this 3 to our answer, and then for this 3 again we're going to go to all 4 directions. This moving to all 4 directions will keep happening until this entire DFS gets terminated. So in this case 3, you see 7 got added to the visited set as well, because in the case of 3, if we don't add 7 to the visited set, we'll again add that, we'll add that 7 again in the case of 3 as well. We don't want that. That is why we are maintaining a visited set. So in the case of 3, we added 3 to the answer, then we move to the all 4 directions. going right here gives us a 0 because there was a land cell here, so that's a 0. Going up gives a land cell 0, going down gives a land cell 0, and if we go left we see 7, but we can't add to the answer because 7 is already added in the visited set, so that's a 0 again. So far we have got 7 in this, and then now we are dealt with 3. Now the same thing we have to do with 2. So this 2, again we add 2 to the answer because we are at 2, and then again we are gonna do the 4 direction movement from 2, 4 direction movement. So if we take a look, if we go down, that's a land cell, that's a 0. If we go right, that's a land cell, this right here is a land cell, and if we go left, that's a land cell again, so we add a 0, and then again we go up, we reach 7. 7 is already added to the visited set, so we're going to add 0. Also make a note of it that the cells that we just reached 3 and 2 will also get added to the visited set, just how 7 got added. The reason we are doing this is because if we again find it as water cell here with some fishes 8, let's say, this will again go to the 4 direction, which is going to reach 2 again. We don't want to add 2 again to the answer. That is why this visited set is very crucial to avoid us adding duplicate answers. So in this case, if we add everything, we get 7, 3, 10 and 2, 12. So if we start fishing from this cell right here 7, we're going to end up with 12 fishes. So and then again if we do it for 5, which is the final one, we'll have to add 5 to the answer, that's a 1. Then we move to the all 4 directions. Out of these 4 directions, these 3 directions get terminated because of the land cell and out of bound, so that's a 0, 0, 0, and then again we reached 1, so we add 1 to the answer. 5, remember, got added to the visited set because if it's not added, if we do the 4 directions for 1, 5 will get added, we don't want that. So in the 4 directions of 1, 5 is added to the visited set, we will add a 0. These moving left gives us a land cell, that's a 0, moving right gives us out of bound, that's a 0, and going down gives out of bound, that's a 0. So final for this one we are getting 6. So out of all the values that we found, 1, 7, 6 and 12, the max is 12, so 12 is what the answer will be. So this is how the recursive DFS is going to work now, and let's try to code this up, we'll understand the algorithm much better. So again, this is a grid problem, we are going to iterate this grid. So we need the row and column values. Whenever there is a matrix defined, it's always better to get the row and column values defined ahead, so that you have easy way iterating it. So that's one, and then again we need the visited set as we discussed, and then max fishes, let's define that as 0 for now. And what else we need? We have the visited set, we have the max fishes, and that's it. Now let's quickly define our recursive function, which will be our DFS. So for each row and column, what we are basically doing, for each row and column we are gonna add the fish that we find at that value, at that R and C, the fish that we find, and then again we are gonna have to call this recursive function again in going in all the 4 directions. So that's r comma c plus 1 comma r plus 1 comma c plus DFS r comma c minus 1 plus DFS r minus 1 comma c. We add whatever fishes we have at that particular grid, and then again we move in all 4 directions. This is how we are getting a value for a particular grid. But before we do that, we'll have to add this r comma c to the visited set, so that when we are doing the DFS, we again don't get this when we are moving in all 4 directions for this part right here. So we need to add this r comma c again back to the visited set. So that's how how we are getting the value for a particular grid. Now we need to define how we are going to terminate a particular DFS. How are we going to return a 0, like with the cases we saw, if it's going out of bound, or we reach a land cell, or if the r comma c is already in the visited set. That was the 3 conditions. So let's define those 3 conditions. First is if the row is greater than, these 4 conditions that you see is nothing but the r and c values going out of bound, that's one. And then again what we also need to do is r comma c is in visited. If this is true, then also we have to terminate the DFS, or we reached a land cell, right? If we reach a land cell, in all these cases we are going to return a 0, basically meaning we are terminating that particular recursive function, we are terminating it. If it's going out of bound, if it's in visited set already, and if the value it's a land cell, in those cases we terminate our DFS. Now our DFS function is defined. Now let's quickly kind of iterate this entire matrix that they have provided us, and then we're gonna perform the DFS for these particular RNCs. So what is the condition for a particular RNC value to have a DFS getting performed? It should not be a land cell firstly, and it should have some values. That's one. And the other thing is, do you think there's any point doing a DFS for a value that we already visited? There's no point. That's added work. Like let's say we started at 7, right? We added these 2, we added these 3. These are again getting added to the visited set. So we did this for 7. Further down the line, we'll again reach at 2 back again. So do you think there's any point doing for 2 again, because we already covered this 2 when we were covering for 7. So there's no point doing for 2 now. So this is where we're going to have 2 checks. If grid R comma C is not equal to 0 and R comma C not in visited, only then we're going to get a count, which would be nothing but the DFS of that value. We are now calling that the DFS for that particular R comma C. Whatever count we get, that max fishes, we're going to update it with this count. We get the maximum. And then in the end, we're going to just return this max fishes value. Alright, as you can see, all the test cases are getting satisfied. Let's submit this. So as you can see, it's satisfying all the test cases, and the time complexity for this one is going to be of order of O of m cross n.